Welcome to The Explainer. So, today we are going to pull back the curtain on a huge question in the tech world. How does an app go from just a simple idea to a massive global service? The kind that can handle millions of users without even breaking a sweat. It's a question that every single successful tech company has had to figure out. And spoiler alert, there's no single magic bullet. It's really a fascinating journey of growth, a lot of creative problem solving, and honestly, some seriously clever engineering. So let's start at the very, very beginning. And you might not believe this, but even the biggest digital giants you use every day, I'm talking the Amazons, the Netflixes of the world, they all started right here, with just one single, lonely server. That's it. Everything, and I mean everything that made that app work, the code, the user data, the whole shebang, it was all crammed into one single box. All right, let's dive into this initial setup. We'll call it the humble beginning, or what engineers would just call the single server phase. I mean, it's simple, it's clean, and for a brand new app, it's pretty much perfect. But as we're about to see, it has some pretty big limits. Okay, so how does it work? Well, it's basically a simple three-step dance. First, you type in a web address. Your browser then makes a quick call to something called the DNS. You can seriously just think of it as the internet's phone book, and it looks up the server's specific IP address. Once it has that address, it sends a request straight to it, and our little all-in-one server does its thing and sends the web page right back to you. Easy, right? Simple and super effective. Now this setup, it's perfect for day one. But what happens on day two? What happens when 1,000 users show up? Or 10,000. All of a sudden, that single server becomes a huge risk. It's a massive bottleneck. And think about it. If that one box crashes, your entire app, your whole business just vanishes from the internet. Poof, gone. So clearly, we need more power to handle all this new traffic. But how do we get it? Well, there are two fundamental paths you can take. And this choice right here is one of the most important decisions you'll make when building a big system. Do you scale up or do you scale out? Okay, so you can either scale up, which means making your one server bigger, stronger, more powerful. That's called vertical scaling. It's kind of easy, but you'll eventually hit a hard limit, a physical and a financial wall. Or you can scale out. This means you add more servers to create a team. That's horizontal scaling. And let me tell you, for true, massive growth, scaling out is the absolute game changer. All right, so we've decided to scale out. We've got a whole team of servers ready to go. Great, but now we have a new problem. When a user's request comes in, how does it know which of our many servers to talk to? We need someone to direct traffic. We need a traffic cop. And that's where this thing called a load balancer comes in. Its one and only job is to be that traffic cop. It sits right in front of all your servers, and it smartly distributes all the incoming requests so that no single server gets totally overwhelmed. And this is why it is such a massive game changer. So first off, you get what we call high availability. Your app stays online even if one of the servers fails. The load balancer is smart enough to just stop sending traffic to the broken one. Second, you get insane scalability. Need to handle more users? Just add more machines to the team. Easy. And as a really nice bonus, it makes things more secure by hiding all your servers from the public internet. Okay, fantastic. We've scaled our web servers. They can handle tons of traffic. But in solving one problem, we've just uncovered another one. Now all of those servers are just hammering our single database with requests. It's become our new weak link, our new single point of failure. And if that database goes down, the whole app is completely useless. So, how do we fix this? Well, the solution comes from a really interesting insight about how we all use apps. Just think about it for a second. When you're on social media, you probably scroll and read dozens, maybe even hundreds of posts for every single one you actually write, right? This basic behavior that we read way more than we write is the key to our next move. What we do is use a strategy called replication. Basically, we make copies. So you have one central master database that handles all the writes. That's all the new posts, the updates, everything. At the same time, it's constantly copying all that new data over to a bunch of replica databases, sometimes called slaves. And these replicas, their only job is to handle all the requests for reading data. This is how you spread that massive load. Okay, so at this point, our system is pretty strong. It's resilient. But to serve a truly global audience, it also needs to be lightning fast for everyone, no matter where they are in the world. So the next question is, how do we give our app that global speed boost?
We've got two main tools in our toolbox for this. First up is a cache. The best way to think of this is like a super fast, short-term memory for our data. It keeps frequently used stuff, like, say, your profile page, ready to go, so we don't have to bother the slower database every single time. And second, we have a CDN, or a content delivery network. This is basically a global network of servers that stores copies of our static files, like images and videos. So a user in Tokyo gets the app's logo from a server right there in Japan, not from all the way over in New York. And that makes things load, well, almost instantly.
All right, we are in the home stretch now. We've built a system that's strong, and now it's fast. So it's time to put all of these pieces together, add the final touches, and really see what an architecture that can handle millions of users looks like. So, a super important principle here is making what's called a stateless architecture. All that means is we take user-specific data, like whether you're logged in, and we move it out of the individual web servers and into a shared central place. Now, why is that such a big deal? Because it means that now any server in our whole fleet can help any user at any time. This makes our entire system incredibly flexible and way easier to manage. But what about the really heavy jobs? You know, the time-consuming stuff, like processing a video you just uploaded. We can't make the user just sit there and wait for that to finish. So instead, we use something called a message queue. The web server instantly tells the user, yep, we got it. And then it puts that heavy job into a line. Think of it like a conveyor belt for a totally separate team of worker servers to handle later in the background. This is what keeps the main app feeling super snappy and responsive. And here it is, the whole shebang, the complete million-user architecture. Let's just walk through it one more time. A user's request comes in through the load balancer. It gets routed to a whole fleet of our stateless web servers. Those servers grab data from a super fast cache or from our replicated database system. Any heavy jobs get passed off to the message queue for our worker servers to deal with, and the whole thing is watched over by monitoring tools to make sure it's all running smoothly. See? Every single piece has a critical role to play. So you see, building for millions? It isn't magic. It's really an evolutionary journey. It's about finding one bottleneck, solving it, and then finding the next one. Each step we've just walked through builds on the last one, creating a system that's strong, fast, and pretty much ready for anything. This is how you build for millions. The real question is, what are you going to build?